In this video we'll actually talk about redistribution, right? So the topology, you can see that we have bunch of routing protocols. We have static, EIGRP, RIP, OSPF, which we have already discussed in my previous set of videos. But what are we actually trying to solve here? Even though you have routing protocols configured here, still we don't have the end-to-end connectivity, right? We'll not be able to ping from R7 to R8. The reason? Because we have different protocols, which means whatever you're learning inside EIGRP, right, all the routes which you learn inside EIGRP, they are not available inside my RIP. Similar is the case with RIP as well. Whatever you learn here are not available in the other two protocols, right? The reason why is this happening? Because we have different protocols, right? Now what's the way to fix this? Redistribution, right? So what does redistribution actually do? So you usually redistribute on a router which is at the edge. In this case, let's take R3. So on R3 we have both the protocols, right? We have EIGRP, we have RIP. There are routes which are learned via EIGRP, there are routes which are learned via RIP. So what we do as part of redistribution is we pick the RIP routes and push it under EIGRP. Similar is the case vice versa, right? We pick the EIGRP routes and push it under RIP. Do the same task here as well between RIP and OSPF, and once you do all of that, you will have the end-to-end connectivity, right? So we'll try some of this. So to start with, right? Yeah, so to start with, what have I done? Let's start from here. R7. What is R7? R7 is basically at the end over here. So as a result of that, I have actually put a default route on R7, right? So you can see here, if I do show IP route on R7, you'll see that there is a default route, which means all the traffic which is destined anywhere, it's basically going to go to R1, right? Everything goes here. Okay. Now on the R1, what have I done? I have put two static routes for the networks which are behind R7. So behind R7 we have the 7 network and the 77 network. So what I have done is show IP route static. So you can see here there are two static routes defined, which are manually defined, telling that you want to go to 7 network or you want to go to 77 network, please go to this particular IP address, and that's nothing but my R7. Okay, make sense? Great. Now we have EIGRP over here, don't we? And you see this R1 is kind of like at the boundary of my static as well as my EIGRP network, right? EIGRP is pretty straightly defined. If I have to show you, it's show run section router, right? So this is my EIGRP which I have defined on my R1, right? On my R1. Okay. Okay. So now if you let's look at R2. What's happening on R2? If I look at the routing table of my R2, show IP routes. Sorry, show IP route, right? You see this, you don't actually see the 7 network or the 77 network, which is the R7, right? We are not able to see the static routes. So this network is not seen on my R2. The reason? Because R2 is inside EIGRP, whereas this is inside static. So I need to redistribute. So I go to my R1 and redistribute the static routes inside EIGRP, right? So that's what I'm going to do now. So I go inside my R1, right? Go inside EIGRP 100, right? Now I say redistribute static, right? You do that. As soon as you do that, you can see on my R2, if I hit the refresh, you can see now the two routes, right? The 7 and 77 network, basically the static networks, are kind of learned inside EIGRP, right? And they are kind of the EIGRP routes, right? So the static routes have now transformed themselves into EIGRP route. They have the D mentioned over here, right? And these are the two routes which are now visible on my R2. They were not visible earlier, but after redistributing, they are visible, right? Make sense? Now I need not obviously redistribute EIGRP inside static, because this guy, right, R7, I have put a default route to R1. So irrespective of whatever I do, right, all the packets are anyway going to R1, and R1 is anyway part of EIGRP. So I need not do the reverse, which is redistribute EIGRP into R7, right? Great. So now what did we do? We are able to see the routes of R7 on R2, which means it will also be see on R3, right? We can see, check that out. Show IP route. It's going to happen. You can see here, yes, the 7 and 77 network are seen here as well. Okay. Now let's ping. Let's probably ping these networks, which is 7.7.7. Yeah, the ping works. Great. Which means ideally so we are able to ping from R3 to R7. Good. Can we try the other way around? Will R7 to R3 work? Let's try that. Ping. I'm doing ping to what? R3, right? What is R3? It's basically going to be this one, 23. So this is the IP address, 23.3, right? So if I do a ping here, does this work? No. You see, the ping is not going through. What could be the reason? We are able to ping from one side and not the other, right? From here to here it works, whereas 7 to 3 it's not working. The reason is, right, when when you're trying to ping from R7 to R3, what's happening? The source packet is basically the interface on which the packet is exiting, which is Ethernet 0/0, right? And the source packet is 192.117.7, right? This packet here, the interface IP address over here. And the destination is anyway, yeah, 23.3, 192.123.3. So now the packet obviously goes to R1 because there's a default gateway here. R1 will forward to R2 because it knows about, you know, the 23.3 packet, right? So it forwards to R2, R2 will forward to R3, right? Now when the return path comes, the source becomes 192.123.3, whereas destination is 192.117.7, right? This is the destination. Now the problem is R3 doesn't know about this particular IP, right? Because we redistributed only the static routes inside EIGRP, and static routes were basically only the 7 and 77 networks which were behind R7, right? So if you look at my routing table for my R3, right, you can see a routing table for R3. You don't have the 192.1.17.0 network, which is my this network, right? If I do show IP route, right, this network, the directly connected network 192.1.17.0, it is not present on my R3, right? As a result of that, from here when the return packet comes, it really don't know where to send, right? And as a result of that, the packet is not passing through. So what we need to do here is, along with redistributing the static routes into EIGRP, we should also redistribute the connected routes, which is this one, the 192.1.17 network, right? Let's do that, and obviously you do it on R1, right? So go down to R1. We already have redistribute static, but we now put redistribute connected, right? As soon as I do that, if I refresh here, okay, this was working anyway, but now you can see I have another route, right, which is 192.1.17.0, which was not there earlier, but now it has come in. Basically we have redistributed the connected routes into EIGRP as well, which means now from R7 I will be able to successfully ping the one which was not working here. So now if I try this, there you go, it's working, right? Great. Now the next interesting thing, now because I did where is it, on R1, because I did redistribute connected, what happens? Let's say I introduce a new loopback address, right? Let's say I introduce a new loopback address, which is let's call it as loopback probably 100, and the IP address is basically 11.11.11.11 and 255.0.0, right? So I've introduced a new loopback address, but what has happened is that I've introduced a new loopback address here, but because I've redistributed all the connected routes into EIGRP, right, this 11 network which I ordered also got redistributed, right? Which means my R3 now will have the entry for 11 network as well, right? You can see here the 11 network has come as well, right? Now if this is your use case, then go ahead, use it, right? Because it is very easy, you just need to do redistribute connected. But what if this is not your use case? What if your requirement is that, right? What if your requirement is that you don't want to redistribute every single route which you connect here into EIGRP, but you want to redistribute only specific routes, right? So in that case, we have to use and do a bit of filtering. So we go back to R1. What do we do here? We go back to R1, create an access list. We create access list, probably give the number and say permit. What network you want to redistribute? I want to redistribute only the connected 192.1.17 network and nothing else, right? Go back, put the wildcard mask, and what else? Create a route map. Call it RC because you are redistributing the connected route, right? So route map RC, probably match IP address and the number of the access list, which is 1. So you created an access list, you created a route map. Now do the redistribution. Router EIGRP 100. We did earlier redistribute connected, but we will not stop here. Instead, we will attach the route map which we created just now, right? If I do show run section router, you will see what is the final. You can see here redistribute connected route map -RC, right? So we have redistributed connected, but at the same time put in some condition telling that redistribute only this route and not the 11 network. So now if you go and hit the refresh on this one, you can see you don't have the 11 network anymore, right? The 11 network was getting added earlier because it was just redistribute connected, but now because we have done some kind of filtering, we no longer have the 11 network. Got it? We just have the 17 network. It is connected, and that is the only network which is kind of getting redistributed. Great. So that was something interesting, right? Moving on. So we are done with this, right? From static to static EIGRP, all of this is done. Now we will do the EIGRP and RIP, right? EIGRP and RIP. So first what we'll do is inside EIGRP we will redistribute this RIP routes. Clearly we have to do this on my R3. Let's go to R3, right? Clear this. Let's look what do we have already. Show run section router. You can see we have the EIGRP, we have the RIP as well. What are we trying to do? Redistribute the RIP routes inside EIGRP. So I need to obviously go inside this router EIGRP 100. Redistribute command as usual. What are you redistributing? RIP, right? Now the metric is important. Whenever you are redistributing anything into EIGRP, you need to define the metric of the routes, right? Because you see in EIGRP we use the 5 metrics: the bandwidth, the delay, MTU, and bunch of things are there, right? So those are the 5 different metrics. So you need to define some value for this metrics. So I'm just going to define 1, right? Doesn't matter because that's the only way to reach them. So these metrics will not play any prominent role, but you need to still define them. Great. So I have defined it. So I have redistributed RIP inside my EIGRP, right? What did I achieve? I redistributed RIP inside EIGRP, which means now if I go to any router in my EIGRP, let's say R1, I should be able to see the routes of RIP 4, 5, and all of that, right? Can we do that? So if I go to R1, go to my R1, and what I do is I'm going to do show IP route, and because RIP was redistributed inside EIGRP, now this routes will be learned as EIGRP itself, right? So you can do this and you will see that you have the RIP routes. So these were nothing but the RIP routes, right? The 4, 5, what you see here, right? These are nothing but your RIP routes, right? So that was successful. So we were able to redistribute. Now we'll have to do the vice versa as well. We did RIP into EIGRP, we'll have to do EIGRP into RIP, right? So let's go back to my R3, right? We are doing it on R3. It's kind of like the border, right? So we go to router, my bad, router, we go into router rip, right? We go into router rip, and then now we are redistributing your EIGRP 100, right? You did not define any okay, you'll have to define a metric, right? There are two ways to do it. What we'll do is we'll do it slightly differently, which means I'm going to hit the enter here and then use another separate command to define the metric, right? You can do both of these in the same command as well. I'm just trying a different way of doing it as well. So this does the task, right? Because when you're redistributing anything inside rip has just one metric, or the cost, so I'm just putting one number. So here we were redistributing rip inside EIGRP, and EIGRP has 5 metrics, and that's why we put in 5 different values, right? Great. So now let me just quickly forcefully clear the route, because otherwise, you know, your rip takes a lot of time, right? Just to recap, what did we do? We now redistributed your EIGRP into rip, which means you go inside any of my routers, let's say R5, we should see this EIGRP routes 1, 2 and all of that, right? Let's see that. Let's go to R5 and let's say rip, right? You can see here the 1, 2 and all of that from my EIGRP are learned over here, right? So they got redistributed successfully. So this is done. The last part, we have to redistribute rip into OSPF and vice versa, right? So first let's do OSPF into rip. So let's do this into this, right? So OSPF into rip, which means and obviously I'm gonna do this on R5. There's R5 over here. Let me clear the routes. Yeah, so I go inside router rip, right? I hit the redistribute command. What I'm redistributing, OSPF process 1 and the metric, right? What is this metric? When you're redistributing anything inside rip, I've already told you we have to redistribute and provide the value or initial value to the cost. Rip has just one metric, which is the cost. I'm going to put in 1, right? So now, which means let's come this side, right? So what did we do just now? We redistributed OSPF into rip, right? And we also know rip has been redistributed into EIGRP. So ideally, if I go on say R1, I should see my OSPF routes. Let's see if that is possible. Let's go inside R1, and if I do this, you will see now. You can see 8. Do you see 8 over here? Do you see 6 over here? 6, 8 and all of that are basically nothing but my OSPF routes. They got learnt on my R1. See, we achieved connectivity, so much connectivity, right? Why does this work? Because we have redistributed OSPF into rip, and we have already done rip into EIGRP, right? That's why. Now, just like earlier cases, we need to do the vice versa. It's not just OSPF into rip, we'll also have to do rip into OSPF as well. So when you're doing anything inside OSPF, let's do this again on R5, obviously. It's clear. Okay, let's come here. Router OSPF 1, right? And redistributing rip. And when you're redistributing rip, we need not provide a metric, because rip because OSPF by default takes a metric of say 20, right? Subnets, this is in the new iOS's, this is not required. I'm still going to do it. Okay, does this make sense? Let me think. Yeah, I think it should be fine, right? By default a metric of 20 is added, but if you can even change it if you want, change the 20 to something else. I'm going to retain the default for now, right? Or maybe I can change it. I can show you how we can change it. So I'll just change it. Metric default is 20, I'll change it 25, right? I can do that. So, and then you can hit the subnet command, or I could just simply go and hit the subnets. Even this would work, right? Either way works. So what should have happened now? What did I just do? I redistributed this rip inside OSPF. Okay. So what did this what did we achieve now? right? We have redistributed RIP inside OSPF, but at the same time we have redistributed EIGRP into RIP, right, and static into EIGRP. So basically we now achieved the end-to-end connectivity, which means if I go inside say R8 router, let's go inside R8, and if I do, let's say if I do show IP route and OSPF, because everything was learned by OSPF, you will now see the end-to-end connectivity. See, we have 7.0 and 77.0, right? Where is this coming from? This is basically your R7. So we have now end-to-end connectivity, right? You can ping as check as well. See, it works, right? So we have achieved that. Now a couple of interesting things which I want to call out here is we will talk about, what do we talk about? If you see here, you know, the routes OSPF external types, right? If you see at the OSPF external routes, when they were learned inside OSPF, they got a tag of OE2. What does it actually mean, right? So in OSPF by default the external routes have a seed metric of 20, right? That is what I meant when I was trying to redistribute RIP inside, you know, when I'm trying to redistribute, I said, you know, OSPF assumes a default metric of 20, so you need not provide a metric, right? I told that. So here you see, I told you guys that, you know, I need not provide a metric of 20 because by default OSPF takes a metric of 20, right? So when that happens, you know, the routes basically, you know, or basically I could say this type of metric, right? This type of a setup where OSPF assumes a default cost, right, for all the routes which are getting redistributed. This type of metric, it's called metric 2, and this 2 basically resembles that, right? So to summarize, by default OSPF does not add the cost of the links as the route propagates through the OSPF domain, right? So let's say the RIP route is entering OSPF, whatever the, you know, cost is there when it enters, right, we are redistributing with the cost of default cost of 20, right? Now ideally the cost should have increased, right? There will be a, let's say, a cost of 10 here, another cost of 10 here. So when the route comes from you know, here to R6, it should have become 20 plus 10, 30, and from R6 to R8 it should have become 40, right? But you see on my R8 still the cost is 20, right? The cost is retained, right? No changes to the cost happens, right? So that is why you call this as external metric type 2, and this 2 basically refers to that. Now if you have multiple points, you know, in your redistribution, right? Let's say you have multiple points, right? Let's say you have a path from R4 to R8, then you might want to add the cost of the links, right? You might want to add the cost of the links and not retain this default behavior of the OSPF, because in that case, you know, you would end up getting routing loops, right? So this concepts or this setup where you are adding cost to the link, right, as the route propagates inside OSPF, that is basically metric type 1, right? And we could do that as well. We could probably test it, right? I think by testing we will be able to understand better, right? So I think you have understood the OE2, right? This 2 is because the cost is retained, it's still 20. We redistributed over here, the cost was 20 on R6, the cost was 20 on R8 as well. But now we'll try the metric type 1, right? For metric type 1, let me go back to R5. Now instead of doing this, let me just do no over here, right? And what I'll do now is I'll do redistribute RIP metric, right? But I'm going to say type 1, sorry. Sorry, it's metric dash type, yeah, type 1 subnets, right? So I've explicitly called out the metric to be type 1. Now if you go to my R8 and if I do a show IP OSPF route, you can see the metric has changed. It's no more 20. Now the cost is getting added along the link, right? It was 20 when it came inside, 10 got added along this string and 10 got added along this string. So on R6 it will be 30 and on R8 it will be 40. So you can see on R6 show IP route OSPF, you can see it is 30, right? And you can see the routes, they have changed from OE2 to OE1, right? That's because it is metric type 1. So this is the resemblance, right? This is the meaning of this 1 and 2. So someone might ask you, what is the meaning of this 1, right? That's basically external routes when they are getting redistributed inside my OSPF domain. I have a flexibility of either retaining the same metric throughout the OSPF domain, right, or I can use metric type 1 where I am basically going to add along the links, right, add the cost along the links, right. So if you are retaining the same cost, it is type 2. If you are adding cost along the links, it is metric type 1. Great, awesome. Now I think the last part of this discussion, I want to talk about redistribution using tags, right? Pretty interesting concept. So imagine I have a use case where I want my EIGRP routes to go inside RIP, right? So I want this to happen. EIGRP go inside RIP, and I also want my OSPF routes, right, to go inside RIP, right? Here I want these both, but I also don't want my EIGRP routes to enter my OSPF, and vice versa. I don't want my OSPF to enter EIGRP. Getting? I want EIGRP RIP, I want RIP and OSPF, but I don't want things to go from here to OSPF and OSPF to RIP. So how do I accomplish this? So to do this, we are going to use the concept of tags, right? Let's see, how do we do this? So let's start with R3. On R3, I will go and define, right? On R3, what I'll do is I'll tag the routes, right? So let's say route map, I'll define a route map. Let's say Ethernet, EIGRP to RIP. Good. Let's define a tag. So I'm going to define a tag of 99, right? So all the routes when they are going from EIGRP to RIP, I'm basically tagging them. Okay. Now then I'll go to RIP, router RIP, right, and we were redistributing your EIGRP, weren't we? So we were redistributing EIGRP 100, and we were also giving the metric, right? Metric obviously is 1 because you are redistributing inside RIP. You need to define that cost, and then the route map. Now we attach the route map which we defined here, right? That's it. Now let me force this, do clear IP route. Okay. Now if you go to, say, what did we do? We basically went to R3, and whenever we are redistributing EIGRP routes into RIP, we basically tagged them. Can we see these tags? Yes, we can. So let's pick one router, let's say R5. So on R5, can we see these tags? Yes. How do we see these tags? So let's pick show IP route. Let's pick a route which shouldn't have the tag. Let's say the Ford network, right, which is on this one, 4.0.0.0, right? You can see there is no tag here. Okay. Now similarly, let's pick a route which is supposed to have the tag, which is, say, coming from this EIGRP domain, something from R1, right? So let's say here, there you go. See, we have the tag. So what did we do? We redistributed EIGRP into RIP. At the same time, these routes we tagged them. We tagged them 99, right? So now the original routes of RIP, right, they are still here, but they are not tagged. These routes which got redistributed inside RIP, they are tagged now, right? Great. Now what do we do next? On RIP, right, now when this get redistributed into OSPF, what we'll do now is we will tell that redistribute only the routes, original routes of RIP, and not the tagged routes which came in from EIGRP. That is what we are going to do, and we obviously do this on the boundary router, which is R5. So let's go to R5, right? So we go to R5 and we say route map, let's say RIP to OSPF, right? RIP to OSPF, you're going to deny. What you're going to deny? We are going to deny match of tag of 99, right? That's a tag which we had defined earlier. And obviously the other route map will be to permit everything, right? Route map R2O permit 20, right? So we have one statement of deny where we are denying the match of 99, but the rest of the rest of the tags are we are basically passing. Great. So now what we do is we go to OSPF, router OSPF 1, and we do redistribute RIP, right? Metric type, we had used metric type 1, we'll use the same thing. We had done subnets, keep it. Only thing is we are going to attach this route map which we just now defined, this one. Okay, it's R2 and O, right? What did we do using this? We basically redistributed RIP inside OSPF, but at the same time we told the router that please redistribute only the routes of RIP and not the routes which were tagged 99. So these routes will no longer be seen here. So let's test it. So let's pick a router on R6. Let's go to R6, right? And can hit the show IP route OSPF here. You'll see earlier you had this 1, 2, 3 which were coming from the EIGRP domain. You no longer have them, right? You can see here. Or I can also run a command and I can show you. You can do show IP route and 1.0.0, right? You see network not in table, it's not there. But at the same time the original RIP routes are still there, right? Let's say the RIP routes which is here 4.0, they will still be there. So I can hit this and you can see the original RIP routes are still there. Got it? So how did we solve this problem? We tagged the EIGRP routes, redistributed them to EIGRP, inside RIP. Now earlier what was happening, once the routes come inside RIP, right, even though they were EIGRP routes, they were getting transitioned into RIP routes. Everything inside here were RIP routes and we were redistributing the RIP routes entire OSPF. But now what we did was we tagged the routes coming from EIGRP inside RIP, and when we did the redistribution from RIP to OSPF, we are explicitly telling don't redistribute the tagged routes, right? Great. Now doing it only in one direction is not sufficient. You got to do it in the opposite direction as well, because my use case tells me that I shouldn't have any OSPF routes and EIGRP as well, right? So let's do it on R5. So on R5 what do we do? Let me clear this. So on R5 let me first go inside, let's create a route map here, right? The route map, let's create a route map and we call this as OSPF to RIP. Okay, the tag, let's set a tag which is say 101. Okay, now go inside router RIP and we say redistribute OSPF 1 metric. What metric? Metric is 1 because it is RIP, and the route map, attach the route map which is this one. Make sense? Right? Now what happened because of this? Now we can see the tag for OSPF route on R3, right? We will so we redistributed OSPF into RIP. At the same time we tagged these routes with 101. So if I go inside say R3, right, I will see that they will have the tag. So I can do show IP route, right, and let's say I do 8.0.0, so you can see the tag of 101. Okay, now what I have to do is that when I redistribute this RIP into EIGRP, I need to make sure that I don't redistribute these routes which have a tag of 101, right? So on R3 what I do is I do another route map sorry, I do a route map, and name of the route map would be RIP to EIGRP. We say deny 10, match tag of 101, and what do we do next? Route map R2E, right, and we say permit 20, and now you go inside router EIGRP and 100, right, you go inside router EIGRP and redistribute rip metric is going to be 1 1 1 1, right, because we are redistributing inside EIGRP. You need to put in those initial values for the metrics. And next, route map, attach this route map, which is this one. Make sense? Okay, so because we have done this, now on R1 we will not be seeing this 8 route, right, we won't have the 8 route. So I can show you this. Enable show IP route. Look, we don't have the 8 route, right? See, we have blocked it. So that is what we achieved. We had an interesting use case where we wanted to have the EIGRP and the RIP redistribution happen at the same time, RIP and OSPF, but we did not want the routes from EIGRP to enter here at the same time OSPF to EIGRP. The simple way to do this is tag the routes, tag the EIGRP routes, and when you're redistributing, make sure that you tag them, and that way, when you're doing the final redistribution from RIP to OSPF, what you can say is redistribute all the routes except that ones tagged as say 99, and do the same operation in the reverse way as well, because the use case also tells me that I don't want the OSPF routes inside EIGRP, right? So that is what I wanted to show in redistribution. Thanks for watching. Bye.